We have here an actual JMI era Vox AC50. Now these came in two primary versions, the earlier ones with cathode bias and the later ones with fixed bias. This one has fixed bias. And I've got 3 jobs in front of me before I can even turn this thing on. Now I cheated a little bit. I already disconnected the output board that goes to here, and I disconnected the power cable because it was just in the way for everything else I need to do. So that's not shown. I need to remove each one of the electrolytic caps in the amp. I've already documented their locations, and I'll take note of the values of voltage and capacitance, and I'll get together parts order for that. Then I need to get the schematic and go through and measure every one of these resistors, because these probably are eerie. They might be hunts. These tend to drift an awful lot. This is a cap, but the resistors here. So throughout the entire amp, this section and this section, I just got to get in there and make sure that everything can stay, and anything that cannot stay needs to be replaced with a suitable replacement. And Vox has always been very optimistic about their screen grid resistors. Some little half watts here that have discolored a little bit, but that might be the wax that's on everything. There's wax and goop on stuff here. It all gets covered in a hazy layer of brown dirt over the decades. Anyway, just gonna make sure all this stuff is healthy. And I'll get some new electrolytics on order. But then once all that's out, I've got a bigger job to do. The JMI era Voxes have a 2-part chassis. They have this U-shaped chassis down here that's steel, and then they have this aluminum kind of L. And the aluminum L is bolted to the steel at various points. Here it was held in place originally by the tabs on this transformer. But what can happen, as you can see here very clearly, is the aluminum part gets bent very common. So there's a bend this direction, and it's not all on the same plane. Sometimes it goes farther down, as it's over here where it's unsupported between the transformers, and it comes back up. And it also has a little bit of a curve to it, and this is all boogered up. And you can see that the tabs for mounting this transformer have also bent. There was a lot of force involved. Probably the amp was dropped. So what I need to do, along with everything else, is I'm going to remove all this hardware that holds this to this. And usually I can bend those tabs back where they're supposed to be and put some stainless spacers so that that gap there maintains a straight line up and down, as opposed to pulling the chassis over where that gap is. And once I get all that separate, then I remove all the pots, all the knobs, all the switches, the fuse holder, the lamp, these transformer brackets which hold in place the input jack shield, remove the input jacks, at which point I can remove this panel and clean it and clamp it flush, clamp it back to flat. And then I can go through here and try to unbend this aluminum and put it in a better position closer to having 90-degree angles, at which point I've got some 3M double-sided tape that should put this back in place and hold it pretty well while everything goes back. And it's not just for cosmetic purposes. Some grounds are made to this steel, some grounds are made to this aluminum, and it relies on the contact between the steel and the aluminum for the ground to be continuous. It's not as bad on this one as on a lot of the AC30s I've had come in, but what always happens, because time, dirt, and dissimilar metals in contact, is that there's a layer of dirt, sometimes of corrosion, sometimes of grease and smoke, just gunk that was in the air over the decades, that builds up between any gap between these two surfaces, and it weakens your grounds. So even if I don't have to remove these from each other permanently, I don't have to take this all the way apart, I need to get access to that gap so I can clean it. That can be a little bit complicated because it has these old grommets where the wires pass through both kinds of metal of the chassis. So transformer connections go through here, also down at the output transformer end. And aside from not wanting to mess up the old pretty lead dress over these things, over the years, these have gotten kind of stiff, and there is a coating of wax over all of them, so there's only so much I can move things without causing problems. So I have to be very careful doing this, but it's always been worthwhile just to make sure that the ground is ground is ground. And there are some places like here where this metal of the steel is bent from the weight of this transformer, but it was only clamped in place by 2 screws, and I can't really take the transformer out. I can loosen it a little bit. I'll only be able to straighten this part out a little bit. It'll be better. It would have been nice if they had had a steel reinforcement plate for this, since they only have the 2 screws. This chassis was done because they use more than one output transformer type, and this one has 2 screws. Others would have had 4. The ones with 4 would have had more reinforcement. This would have been less likely to bend, but I'll see what I can do. I'm not trying to make this thing pretty just for the sake of being pretty. I'm trying to make it functional and more, fit in the cabinet better and have good grounds. And as much as I can get it to pretty, that's great, but that is not the primary objective. And as I go through, I've got to take a note of what's just old wax built up like that, and what looks like to be actual heat damage for this resistor, which takes the place of a screen resistor. That's a big dropper, so that'll need to be replaced. Fortunately, while this thing is not as rugged as a turret or eyelet, this does have a more rugged tag than the ones used on the AC30s. It has a little hook kind of shape. It's much easier to work on these than on the AC30s and 15s, but I still have to be very careful in removing old components not to do any damage. I will report back as I get some of these out and show you what these areas look like once the components have been removed, and then that's where we'll probably end this video because I've got to get a bunch of parts on order. So I got all the caps out, and in the process I discovered that of the electrolytic caps, only these 2 hunts were original. They've been recapped maybe in the early 80s, some Unicons, some generics. This is original and not very happy resistor, obviously. But I've got it all cleaned out. First pass of cleaning in terms of the board and getting all the cobwebs and hair and the grossest bits of stickum out with isopropyl. That's why it's here on this paper towel. All the excess drips out. And now I have a clear path to go in here and compare to a schematic and measure all these things. I imagine next time you see this amp, either these will have been replaced or I will have a plan in place already with some parts on order. And I don't think I have that many 1 watts. These are 1 watts. So I'll probably do it all up with some 1 watt carbon films. So I'll place a parts order for that as well as the replacement caps. It's going to be interesting finding the right option. This is a dual 16 450 volts. So is this. Yeah. And so these were originally here, as you saw. But this is not a value that anyone is making as far as I'm aware of, dual 16s. But each one of these could be replaced with a 16 450 or a 22 500. And it may be that these just don't go back in the amp. Or if they're in the amp, they won't be holding any caps. We can't get these again, so what are our options? It's always kind of interesting seeing how things were built in the past and what changes we have to make it viable going forward. This thing will be very viable going forward, but it's going to be a bit. Until then, thanks for watching.